Hello and welcome to the 8th speedrun of today. And this time we're going to be finishing off some of the absolute value questions, and this time we're covering absolute value inequalities. And so let's jump right in. So absolute values are very useful. Well, properties of absolute values are very useful in solving inequalities. I'll just go over the most important ones. First of all, if the absolute value of A is less than or equal to B, then A is clearly between negative B and B. And if the absolute value of A is greater than or equal to B, then A is less than or equal to negative B, or A is greater or equal to B. Okay, that was pretty much it. So let's look at some problemas. So the first problems want us to solve the inequalities and check your answers graphically. So the first inequality we want to do is we want to look at 2x plus 3 is less than or equal to 6. Okay, so in this case, we know that negative 6 must be less than or equal to 2x plus 3, and that must be less than or equal to 6. This is the inequality we get. If you remember from the earlier property, if we have something that is less than b, then negative b is less than or equal to a, which is less than or equal to b. So here we want to subtract 3 from both sides to get negative 9 is less than or equal to 2x, it's less than or equal to 9, and so negative 9 over 2 is less than or equal to x, which is less than or equal to 9 over 2. And we can check this inequality. We want to graph this. We have y equals 6, which looks like this kind of line. I'll draw it in a different color. And the inequality of 2x plus 3 looks something like x equals 0, yeah. It will look something like this. And so the region in which 2x plus 3 is less than 6, in this case the y value of the red line is less than the y value of the blue line, well, that will be this region here, which is when negative 9 over, oh, actually, am I being silly? Oh, okay, why, no, sorry, no, I've just been silly. Subtracting 3 from 6 should be 3, and so therefore this should be 3 over 2. So this probably wasn't an exact graph. Let me just take that out. And the graph probably looks something a lot more like this. Nope, it's too perfect, like that. And the area we're looking for is here. Okay, so that was one down. Next one we have 3 minus 2x is less than 5. And again, we can use the same property that negative 5 is less than or equal to 3 minus 2x is less than or equal to 5. Negative 8 is less than or equal to negative 2x is less than or equal to 2. And so, of course, 4 is greater or equal to x, which is greater or equal to, wait, am I doing this right? Negative 8, negative 2x is between 2 and negative 8. So negative x, oh, I can't draw, it's between 1 and negative 4. So x must be, yeah, I think x is between 4 and 1. So 4 is greater or equal to x, which is greater or equal to negative 1. So if we graph this, we should get something. Well, y equals 5 looks like that. And 3 minus 2x three minus 2x looks like this. Oh, but it's the absolute value. So 3 minus 2x would look like this. Sort of. Yeah. So it will look like this, and so we're just getting this green region inside of here. So yeah, that seems good. So let's move on to the next function. And next function is that 2x plus 3 is less than x plus 3. And so what we need to check is that, first of all, 2x plus 3 is greater than x plus 3. And also that negative 2x plus 3, negative 2x minus 3 is greater than x plus 3. And I think this should give us two different boundaries for this equation. So 2x plus 3, this would be x is greater than 0, or negative 6, 3x is less than negative 6, so x is less than negative 2. So these would be our two answers, I believe. So as long as x is greater than 0 or x is less than negative 2, then yeah. And I just checked it with the mark scheme, and it's also correct. So this is the correct answers. So moving on to the second section, we want to solve the inequalities graphically. Okay. So we want to solve these inequalities graphically. So the first inequality is x plus 1 divided by x minus 2 sorry, I read it wrong. Oops, that's why. I was like, there's no way this can be the equation. Sorry, it's actually x plus 1 divided by x minus 2 is greater or equal to negative 2. And so, what do we have here? But this is still like, huh? How can this be the inequality? Okay, I'm looking at the mark scheme, and the mark scheme's wrong. Because they've said that this should be equal to 2 and not negative 2, so I guess we'll solve that equation, but that was why we were getting it wrong. So we know that x plus 1 over x minus 2, the absolute value of that is also equal to the absolute value of, we just take their absolute values individually, and therefore we know x plus 1 is greater than 2 times x minus 2. So, well, if we graph this, if we have x plus 1, the absolute value of x plus 1, it would look something like this. And if we have the absolute value of 2 times x minus 2, it would look something like this. Oh, I guess the question is, how do you find it graphically? I mean, it's clearly this area here. So I guess we have to find intersections. I guess we'll just solve them manually. So we know there's an intersection here, and we know there's an intersection up here. And what I would assume is that those two intersections are when x plus 1 equals 2 times x minus 2, and when negative x minus 1 is equal to 2 times x minus 2. So let's just solve these. So the first one would be x plus 1 is equal to 2x minus 4, and 5 is equal to x, so x equals 5. So that is the upper bound, I think. But let's just check. And negative x minus 1, this one is equal to negative x minus 1 is equal to 2x minus 4. So we have 3 is equal to 3x, and x is equal to 1. So, yep, this would be x is equal to 1, and so it would just be between x equals 1 and x equals 5. So, for the final equation, we have 2 times x plus 2 minus x plus 5 is less than or equal to 4. So again, to make it easier to graph, I'll make it 2 times x plus 2 because okay, you could do this on a graphical calculator, but if you don't have a graphical calculator, I would do it this way. I would advise you to do it this way. So we have 4 plus x plus 5 is greater than 2 times x plus 2. So 2 times x plus absolute value of x plus 2 would look like this. And 4 plus x plus 5 would look like it would look like this. Something along those lines. And so we need to find, actually, I need to zoom out of this graph a little. So if we draw this on a larger scale, we would have 2 times x plus 2 as something that looks like this. And 4 times x plus 5 as something that looks like this. And so we need to find this green region. So we know one root will be positive and one root will be negative. And as usual, we can make these two different equations to help us. We have the first equation, 2 times x plus 2 equals 4 plus x plus 5. And then negative 2 times x plus 2 is equal to 4 plus x plus 5. So this one is equal to 2x plus 4 is equal to x plus 9. In this case, x is equal to 5, so that should be one root. And let's check for the other one. So negative 2x, oh, it's in green, no. Negative 2x minus 4 is equal to x plus 9. And so we have negative 3x is equal to 9 minus 4, no, sorry, 9 plus 4, 13. So x is equal to negative 13 over 3. So these should be the two bounds. And yeah, that should be correct. So that was all for this speedrun. And after this, we'll be getting onto the final speedrun of day 6, and I hope to see you there. Bye bye.